All right, today we're going to pull back the curtain on a piece of internet magic that you use every single day, probably without even realizing it. It's called network tunneling. And believe me, it's the secret sauce that makes everything from your work VPN to the entire future of the internet actually work. Okay, so picture this. You're at a coffee shop, you fire up your laptop, connect to their public Wi-Fi, and then log into your work VPN. Suddenly, bam! You're securely accessing company files like you're sitting at your desk. How? How in the world does it create that secure private bridge over a totally public and unsecured network?
Well, the answer is a really clever illusion. It creates a private path through the public internet. Now, it's not a physical wire, but for all intents and purposes, it acts just like one. This is the whole idea behind a virtual tunnel.
So why do we even need to build these tunnels in the first place? It turns out they solve two huge, fundamental problems that are absolutely critical for how the modern internet works, both for private companies and, well, for the entire globe.
Okay, first, let's imagine your company has two offices. Think of them as two private little islands. And separating them is the vast, unpredictable, and totally unsecured ocean of the public internet. Tunneling is what lets these two islands talk to each other directly and securely, almost like they're connected by a private bridge. This right here is the basis for pretty much every corporate VPN out there.
Now, the second problem is on a whole other level. It's a global one. The Internet's original address system, which we call IPv4, is basically full. There are no new addresses left. And this isn't some new crisis. As this report points out, the experts saw this coming way back in the 90s. It's been a massive roadblock for the Internet's ability to keep growing.
So how can one technique solve both a security problem for a company and an address shortage for the entire planet? The key is a wonderfully elegant process called encapsulation. It sounds complicated, but the concept is actually beautiful in its simplicity. At its heart, encapsulation is exactly what it sounds like. We take a complete package of data, a packet, and we just wrap it inside a new, bigger one. That new outer packet is the only thing that travels across the public internet, keeping the original packet tucked away and safe inside. Honestly, the best way to think about it is mailing a letter. You write a letter, put it in an envelope, and write a private address on it, right? Encapsulation is like taking that sealed envelope and putting it inside a second, larger envelope. You then write the public internet address on the outer one. That's it. That's encapsulation in a nutshell.
Okay, so much for theory. Let's make this real. We're going to peek under the hood of a really common tunneling protocol called GRE, which stands for Generic Routing Encapsulation. This is where we'll see exactly how that envelope in an envelope trick actually plays out.
And check it out. This table maps perfectly to our mail analogy. The delivery header, that's our new outer envelope with all the public addresses. The payload, that's the original letter and its envelope totally untouched. And that GRE header in the middle, think of it like a little note to the person receiving the mail that says, hey, there's another package inside and here's what to do with it. So let's follow the data on its trip. It starts out as a private packet on network A. When it hits the edge of the network, the router there wraps it up. It encapsulates it. This new, bigger packet then happily cruises across the public internet, its contents completely hidden. Once it arrives at router B, that router simply unwraps it. It decapsulates it. And boom, the original private packet pops out, safe and sound, and is delivered.
Okay, so that makes perfect sense for connecting those private islands. But what about that much bigger problem? The entire internet running out of addresses. Well, believe it or not, this very same principle is what's making the internet's next evolution possible.
You see, the original system, IPv4, had a hard limit of about 4.3 billion addresses. Now that sounds like a lot, but in a world with billions of people who all have phones, laptops, watches, and even smart refrigerators, yeah, 4.3 billion just wasn't going to cut it.
The new system, IPv6, doesn't just solve the problem, it obliterates it. The scale is just staggering. We go from 4.3 billion addresses to 340 undecillion. That's a number so big our brains can barely comprehend it. It's a 3 with 38 zeros after it. We could assign trillions of addresses to every single person on Earth and not even make a dent.
The reason for this astronomical jump is actually pretty simple. Old IPv4 addresses are 32 bits long. New IPv6 addresses are 128 bits long. Just by quadrupling the length, we get an insane number of new possibilities. The problem, though, is you can't just flip a switch and upgrade the whole internet at once. For a long time, these two systems have to exist together.
And this is where tunneling becomes a global hero.
We use that same encapsulation trick. We can take a shiny new IPv6 packet and just stick it inside an old IPv4 envelope. This allows the modern parts of the internet to talk to each other across the older parts. Tunneling is literally the bridge that's making this decades-long transition possible without everything falling apart.
So let's bring it all home. This isn't just some obscure, nerdy networking concept. Tunneling is a true, invisible workhorse that quietly enables huge chunks of your modern digital life.
Seriously, think about it. The VPN on your laptop? That's tunneling. Connecting corporate offices across the globe? Tunneling. The entire planet shifting from IPv4 to IPv6? You guessed it, only possible because of tunneling. It even lets us do other cool things like sending a single video stream to thousands of people at once over networks that weren't designed for it.
When you boil it all down, tunneling is this simple, powerful, elegant idea. Wrap one kind of data inside another so it can cross a network it couldn't cross on its own. It's the concept that's holding today's internet together and paving the way for tomorrow's. So the real question is, what new islands will tunneling help us connect next?